Glad that you're all continuing to join us. We just got a few more sessions left on day 4 here of the conference. As a reminder, just like we say in every session, this is brought to you by our generous donors and supporters, which includes, of course, all of you for being here, Holistic Think Tank, Cortico, Antioch University, Teacher-Powered Schools and Education Evolving, as well as Unruler. Again, we appreciate you all being here. I'm super excited to introduce Sunil Singh. Sunil has been HRP's founding board president and with us for a few years now, who is actually about to transition to be kind of a employee of HRP as we kind of grow, evolve, and expand our organization. Sunil's really taught us a lot about math and just about like content and pedagogy and school and education, both through his books like Pie of Life and Chasing Rabbits, but now even music with Sonic Seducer, and I'm sure he'll dive into all of that. But Sunil, it's great that you're here, and take it away.
Super. Thank you, Nick and Chris. And it feels like, I know it's the second one, but it feels like, you guys become all pros at it. And, I can only look forward to the future iterations of this conference, because I think there's just so much to impact just in terms of the actual workshops, but even just how we meet as people now. And so, this is a brand new presentation. I mean, there's some slides I've used from previous ones, but when I came up with this idea of, rehumanizing mathematics with better content, pedagogy, and purpose, I had to really put everything together. So I'm going to say something paradoxical. Fasten your seatbelt, because we're not going anywhere. There's going to be a lot of turbulence in terms of the ideas, good turbulence, but this is all about awareness. I mean, it's like that Simpsons episode where Homer's climbing the murder horn, and there's like 3 different mountains. We're barely going to scale the first one. So it's just all about awareness at this stage. I did use this David Orr quote, which was in a session. I forget who gave the session, but it was in a session, and Nick had posted on Twitter. And I think it really captured at least some macro idea of what I want to sort of convey in this 50-minute session. So please keep that in mind as well. And I'm going to highlight each of those bullet points. Here's better content ideas. Here's better pedagogical ones. Here's better purpose. So it's a very clear demarcation of where it is in the presentation. I always start with humor, if you can find it. I've just been delving into a lot of Gary Larson lately, just because, his books are somewhere here. And until I saw this YouTube video in terms of, what was he actually doing with one panel cartoons that was limited by, is he's using this idea of, this concept, which you can see in medias res in the middle of things. And this cartoon here, for me, really sums up math education, probably education in general, always A to B, always A to B. It's the external vector, for getting a job, being a good citizen, all important things. But where is the internal one for your own purpose, right? For your own value, for your own currency of living as a human being in society before you get to society? For me, that's a B to A proposition. That's why it's like in that cartoon, everyone's wanted to do things A to B. No one's ever wanted to do things maybe not literally in the reverse order, but that kind of thinking. So, a little bit of Gary Larson there for us to sort of chew on. They always say start with why. So again, cartoon, why are you here? Why are you here right now in this virtual conference, in this moment, for this specific workshop? What brings you here as an educator, teacher, parent, concerned citizen, all these things. I think we always have to be asking, what are we doing and why are we doing it, constantly on low simmer. This one's maybe hopefully to a rolling boil. Of course, it was implied Simon Sinek above, because his whole book and his TED talk, which he did on flip paper, start with why. This goes back to the David Orr quote, and it really, I'm never that person who likes to sort of over dramatize things, but we are at a fork in terms of, paths and roads. It is a binary proposition. We're either going to let things go pear-shaped, or we're going to go all in and create a world. And I'm going to be talking about a world of mathematics, which really is for better content, better pedagogy, and better purpose for everyone. That's the thing. Mathematics in the beginning was really, let's create as many engineers, scientists as possible at the cost of whomever doesn't make the cut. I mean, no one wrote that as a mission statement, but that's what it's been. So here's our why. I mean, there's a couple of whys I'm going to share, but here's your visual why. And there is very little opinion in this presentation. This is historical fact. You want to just Google math anxiety, etc. I mean, that's just one of the window panes, but this is the history, the general history of a sizable population of students, now adults, their experience with mathematics. And math education thinks this is an okay tax. They even think, they have even workshops about overcoming math anxiety as though it's some sort of inevitability. You know how sick that is? That you're actually going to get sick with math, but we can have intervention plans to help you. How about you not have students getting sick with math to begin with? Because that was its history prior to education getting involved with it. Because everybody explored or mathematics throughout history. And so I've used this slide many times, not going to go into detail. I just randomly took images from Mathagon of mathematicians throughout history. I just made my own collage. So students don't see this world. They don't see mathematics transcending races, cultures, civilizations, time periods, probably even socioeconomic conditions. You know, there's an assumption that everyone who's in mathematics now must be, you know, well off or middle class. So there's a lot of classism too. So look at just all the different, you know, obviously when photography wasn't around, and different clothes, different customs. All of these people were mathematicians. This is what a mathematician looks like. It looks like anybody from time. So when students stare at that metaphorical figurative window and they see that bleak, they don't see this. They don't see anything reflected back that looks even remotely like this. If you were asked to be one slide why we need to recalibrate mathematics, here it is. It's kind of funny, it's kind of not. You take that license plate, you show that license plate, next week, and let's say every class from second grade to high school, and you ask students to point to the Arabic numerals. I would say over 95% are going to point to the lower right, which are Eastern Arabic, and the ones obviously in the top left, upper left are Arabic or Hindu Arabic. So if we don't even have the story of our basic numbers right, then we've already veered off the path. Like it's a joke. Like we don't even know what, like the basic idea of mathematics in terms of its number construction and where it came from, I don't know. And it also becomes fodder for racism. I mean, Shakespeare couldn't have written a better tragedy or irony in terms of where mathematics got off to a wrong start. So really it comes down to, again, the why, because, I think we're much better at this right now, but for a lot of teachers, this probably is the trajectory in terms of what mathematics is. I mean, even I thought so too when I was in high school. I mean, I came from India, which has a rich history of mathematics, but honestly, if someone told me this story, I would think it was mostly, white Europeans in terms of the trajectory. That's what information do I have to give back, right? And so this is from Crest the Peacock, non-European roots of mathematics. I'm not going to go into the whole thing, but look where Europe came in. Europe came in late. Now, we're not taking away all the things advanced in mathematics. Telling stories in terms of better pedagogy is putting the pieces in, because if you don't put in those previous pieces, guess what? Some of the concepts you teach in high school are going to be incorrect. They're going to be wrong citations. They're going to be pedagogically wrong. I'm going to show you those examples. And just look at all the rich history that happened prior to. But we always refer to something as the Dark Ages through that Eurocentric lens, because around the time of the 10th, 11th, 12th century, in the Arab world was the height of algebra. It wasn't dark for them. So again, all this stuff, we have to really address in terms of better content, better pedagogy, and better purpose. And I love this Sumont kid quote, because really, if we stop telling stories or don't even know the stories, we lose sight of who we are and what we're even doing here. There is no connection for students to learn math other than it's going to get me a good job and society tells me it's important. Where is the sort of richer raison d'etre that's going to pull every student in, because every student in the classroom has themselves reflected somewhere in history, some sort of important mathematical contribution, which is part of the whole thematic development. And this is the story this is the most important story. It's been slow failure. And what is communicated in the classrooms? Fast success. As Jordan Rappaport, mentioned, like sitcom sort of size problems, that everything must be completed, in the classroom and correctly. That is so disingenuous and not the narrative of mathematics, because some problems, like Fermat's last theorem problem, took 352 years until it was solved by Andrew Wiles, presented in 1993. So it takes generations and centuries, and this is the true narrative. Students don't even have this as a bedrock, as a foundation to even cope, and this probably causes some anxiety by not having this story in. Okay, so let's get to better content. Again, we've got about 35 minutes. I am going to make an impassioned plea of what better content looks like, what better pedagogy and better purpose. Again, we're not going to really go anywhere, because there's so much more I could share in content and pedagogy purpose. I just want to get like a little bit, like if you're like eating a meal, this is like one sort of taste of the appetizer, and there's many more appetizers in a full meal, dessert and coffee and aperitif coming later on. So this is just a taste, but here we go. Better content. So why not start with, again, numbers? Brahmagupta, who is not only a mathematician, he was a astronomer. He wrote the book Brahmasputha Siddhanta. It may sound hard to pronounce in the beginning, but really it's not. And anytime you're going to present anything from the past in mathematics, same thing with students' names, take time to learn it. Take time so it feels comfortable in you, because then it has some more authority that you took time and patience and respect to learn it. So what happened was that the chapter on zero probably wasn't understood too well. Zero is supposed to be the lowest number. You can't have less than zero energy or matter in the universe. You can't, it's impossible. If you have negative temperatures, that is still something which has, absolute zero is the lowest temperature. If you have something like a proton, which has a charge of +1, or electron, which has a charge of -1, you're not going to say the proton is bigger than electron. It's about magnitude. So that's just setting you up for what I want to show you next. Again, you're all looking virtually on your laptop or desktop. You can look at your keyboard right now. You can see 0 is after the 9. Why is 0 after 9? It's supposed to be before 1. Well, it's because we've only taken as a placeholder. That's the only purpose. It's a utility purpose, which basically came about through some loss and translation stuff. 0 is supposed to be the lowest number. This is a work of Jonathan Crabtree, an Australian who spent 33 years investigating why 0 went all squarely. This is what maybe our number line should look like. So therefore, there's no confusion about if you were to walk 5 miles west and 2 miles east, of course, walking 5 miles west is more. Try imposing that on a number line, and that's why kids get confused about positive and negatives. And it makes it worse because we pathologize these negative numbers, because you learn them in 5, 6 years later in grades 5 or 6. Oh, we're going to learn negative numbers. There was a divorce between that whole positive, 0, negative, which is completely unhealthy. That's not the way you're supposed to teach mathematics. Those numbers, they're all supposed to come as one package, positives, zeros, and negatives. And let me give you an example where that might come up. So here's a question they do like later in middle school, to subtract 5 negatives. Listen to what I said. I didn't say 2 minus minus 5, where I basically become like this sort of get sloppy with the language. You know, that minus sign in between those numbers is a verb, subtract. The 5 negatives and 2 positives are objects. Those are nouns. It's very careful, important to use proper language. So this question you and I did, you know, oh yeah, two minuses make a plus, 2 plus 5 is 7, do 30 more. And of course, you're going to get a decent mark on the quiz. That means nothing. So let's see how it looks like. Well, what you do is you say, I'm going to add 0. And kids will go, well, 0 does nothing. Perfect. They understand 0. That if you introduce 0 into this sum, addition subtraction question, it doesn't do anything. They understand 0. And now you get to be a bit sly and say, well, guess what? I wish I had 5 negatives to withdraw. I don't. I'm 2 positives. Sorry, I don't got any of that stuff, speak in that sort of vernacular. But 0 can take on many forms. And one of the forms it can take on in this particular situation is if you had 5 negatives and 5 positives. So the idea of 0 pairing becomes very powerful here, and kids have autonomy and creativity to create the 0 pair. You can do -6 plus 6 if you want, but what do you want to get rid of specifically? You wish you had 5 negatives to withdraw. So now you do, you sort of set them off to one side. Just think of them as objects. Don't think of them as the abstract Arabic numerals. You got 5 negatives, same number of objects, subtract same number of objects. All of this gives you 0. And you can see by symmetry, we're going to get 7. You're not going to do this question every single time like this, but in terms of folding in factual fluency, pedagogical, and conceptual with historical fluency. And I'll just give you a sort of a ground roots of what this looks like. Here's a question that every kindergarten, first grade kid would probably get right. They might make a mistake if they don't withdraw with their finger correctly, but that's the only one. Not one kid does not understand what needs to be done in terms of withdrawing those 4 red tokens from the 7. But I've changed the question. This is actually a 7th grade question, but I've tried to make it simple, but I'm going to make it more complicated. This is even though without the visuals, this grammatically is correct. I gave this question to my daughter before she knew what negatives were. She was on her iPad watching Fuller House when she was in 3rd grade. Occupied, she got the right answer. She told me 3 negatives because the language made sense. And of course, here's the nonsense we do in middle school, -7, -4. I don't know what that means. Students don't know either. This is where it all went pear-shaped quite early. I've used pear-shaped twice. I won't use it again. But this is what I'm talking about in terms of better content. You have to get the basics right. And of course, folding it into with math history and storytelling is the best form of content and pedagogy. So that's where storytelling comes in, so important. I'll give you another quick example. Here's a pretty simple question. I used to give a family math nights. You got 2 loaves of bread with Unifix cubes. How would you divide this among 3 people? This was the most common response that parents and kids did. And it's right. I mean, everyone got the same number pieces of bread, 4, right? I mean, we had a total of 12. So, but the thing is, 2 people got the same looking loaf or kind of bread and the other person. So this is a nice discussion of equality and equity. So the response that most people don't put forward is this one. So this is both equal and equitable, and everybody got 1/2 of a loaf and 1/6 of a loaf. And soon as you present this as a possible answer, you then get into history. You get into this. You get into the British Museum, where the rind, but I'm going to call it the Ames papyrus, because the Rind papyrus was named after Alexander Rind, who founded in 1858. But Ames was the scribe. He wasn't even the person who created the problems on the Rind papyrus, but at least give closer attribution to the source. So we like to call it the Ames papyrus. And here it is. Goes back to 1650, BCE, and it's got these unit fractions on this papyrus, which sits in a museum. When would kids ever think the fractions, the thing they hate the most, sits in a museum, and has been for over 150 years, whatever. So this is, again, how powerful storytelling is, because it binds all the fluencies and makes for richer content. Okay, last one in content, just looking at the time, we're gonna be good. If you haven't seen Last of Us, this is a scene from the third ground baking episode. It really symbolizes the last example I want to do for content. It is really smelling strawberries, something that you took for granted, that small pleasure of a fresh strawberry indicating life. And we don't really look at mathematics like that. We don't look at numbers like that. We take them for granted because it's all about computation. So times tables. I'm all for factual fluency. Absolutely. Sign me up. But can we dig a bit deeper? Because there's two numbers, there's two times table facts on here, which are so pure and unique. There's actually four, but of course, you flip it around, you're going to get four in total from the two. But there's two math facts here, which are that's strawberry. And it's 2 times 3. That's one of them. Because 6 is a perfect number. All the proper divisors of 6, 1, 2, and 3, don't call it, can't include 6, add up to 6. 1 plus 2 plus 3 is 6. So we call it a perfect number. It might seem like a throwaway fact. Okay, fine, it's perfect. That's not bad. And 2 times 3, nothing seems apparent yet, but 2 is a binary number and 3 is a prime. It's actually a Mersenne prime. But if we find the next perfect number after that, which I did with in my daughter's first grade class when she was in first grade with Unifix cubes, 5 kids after 20 minutes found the next perfect number, 28, because all the proper divisors of 28 are 1, 2, 4, 7, 14. And these kids built a tower of 28 using those 1, 2, 4, 7, 14, and it was the same height as 28. That was the visual about how perfect they are. But again, you've got that same idea, binary times you got odd and evens, you got binary times a Mersenne prime, and you also got the beginning of every perfect number is a sum of consecutive odd cubes that starts at 28. And kids got so excited, and I told them we don't have enough cubes to do the next one, which is 496. And I'm staring at you because I've told this story all the time, so I know all the proper divisors of 496. It's 1, 2, 4, 8, 16, 31, 62, 1, 24, 248. If you add up all those numbers, you get 496, and you're getting into mathematical gold territory. Sorry, it should be, oh, I want to go back to the previous one. I can't, okay, my bad, my mouse got stuck. But I wanted to show you how 496 is going to be 16 times 31. And, 16 is 2 to the 4, 31, 2 to the 5 minus 1. And that's going to equal 1 cubed plus 3 cubed plus 5 cubed plus 7 cubed. And I wrote all this on a board when I told the story of perfect numbers. It's almost like the treatise of perfect numbers. But look at all the things that perfect numbers have that we try to teach as isolated concepts. If you teach it all as a story in which you just know these facts, like, the next perfect number at 496 is 8128. Next one after that is 33,550,036. The next one after that is 8,869,589,056. Now, I have not memorized it per se. It's just part of the story because best stories have really good detail, right? And of course, the best mathematics, which is historical, rises like cream to the surface and enters our sort of pop culture world where even media gets a toehold on perfect numbers. But imagine if these were already being taught in schools and kids read media or social media and go, yeah, I learned all about that. They would feel like media is catching up to them, right? So again, better content. And there it is, storytelling. I told a story of perfect numbers, which is albeit a very short story of the 3,000 years. Last content story in terms of better content. Here's a ratio proportion question we give quite a bit. I don't know how many kids care about barley. I just chose a question, which has some racial proportion in it. But if I change one word only, I completely shift the narrative of where this problem will take us. And I'm going to change the currency from dollars to soldi, which is an Italian silver dollar. And as soon as I do that, I make the question historical in terms of who created this question, the time period, everything is now set in motion. It's to go like, exactly in that time period. So we end up in 12th century Bugia. Why are we there? Because Leonardo da Pisa, who we later be named Fibonacci, went with his dad on a business trip. Like he asked his dad, can I go with you? He's 11 years old. He's hanging out at the ports of Bugia while his dad is, doing business, whatever. But he's there at the right place, right time, because all this amazing information is coming up through the Silk Road in terms of the mathematics, which came through the Arab world. You have the House of Wisdom, which is equivalent to the House of Alexandria. There's like 3 books written on the House of Wisdom. And so he got all the information on arithmetic. So that race portion question, guess what? Every single problem kids ever do at some point in the mathematical timeline, we didn't know how to do it. Every single question was a complete mystery. So race portion questions, yeah, we know how to do it now. But back then, you had to take that work to a special scribe or person. So these merchants had to pay extra money to make these conversions for trade and commerce, inheritance. But Leonardo da Pisa eventually wrote a book, Liber Bacci, in the 12th century, 1200, sorry. And this became a primer so everyone could do this lay mathematics, which had a lot of practicality, only because I changed one word. I changed from dollar, I went to soldi, and again, storytelling. So there's the content. It's just the tip of the iceberg. There's so much ideas about content we have to shift, and not for any other reason, but to make it better. And when you make it better, all that stuff about DEI, culture responsive, anti-racist mathematics naturally comes in through the dragnet. That's not I was going to say it's ironic. It's not. Of course, the best contributions for anything have come from us as a collective society and not just one part, right? Okay, so the better pedagogy part. This is much shorter than the content because this is really just neglected pedagogy. Pedagogy which we've never really put into schools wholesale. Maybe, here and there, late 60s, early 70s, it was installed. Really, and there's a lot on this slide, but most of the math questions students have done since time immemorial. If you look on this flow graph of, I forget his last name, Mihaly, it's got like 20 letters. He passed away actually in 2019, just for the pandemic. He's got a great YouTube talk, but most of the questions on this graph do not sit in flow. They sit in anxiety, worry, apathy, boredom. Don't ask me, ask the students. Because most of the questions they've done have not been in flow. They have not been a perfect match of challenge level and skill level and really taking time. And probably some of the things which are missing is, of course, the storytelling element to get them more excited, to push it into flow, because there has some historical or cultural or just human relevance. Most of the math questions we do, you let them sit by themselves, they're pretty inert. They're pretty inert. So who came up? So when I got this image, sorry. Every other pedagogy we're doing, every other pedagogy is cart for the horse. If we don't attend to the one I'm going to talk about, then everything else is like a house of cards, going to fall apart. So this image is to share with you that all the pedagogy, which is currently math education right now, good intentions, it has a place. If you don't put the one I'm going to say, you lead to all the things we've already talked about, intimated at, anxiety, boredom, alienation, and it's the rhythm of education offered North Whitehead. And that the first introduction of our ideas, any ideas, has to be through a wider mouth of a river called romance. There is no need for precision. But guess what math education has done? They've taken precision, an important element in middle school where you have to dot your I's, cross your T's, make sure you're attending to arithmetic, starting getting better algebra. Yes, precision is absolutely important. And then when you exit the mouth generalization, you take precision and generalization with you. You can just have general ideas about mathematics where it applies. Excellent, perfect. But we never did romance. In fact, we doubled down on precision, put it in K to 5, and that's why math education has never gotten it right. It's that simple. It never had a period of romance. And you might be thinking, well, that's kind of like a bit kind of fuzzy. Who is this Alfred North Whitehead? Well, he was a mathematician, educator, philosopher, and writer. He co-wrote Principia Mathematica, which you can see is number 23 on the top 100 nonfiction books of all time, according to Modern Library. I'm sure you can see some ones you recognize. This book, which was written like in 1910, I think the first edition, there's like 193 page proof of 1 + 1 = 2. There's a running joke that no one's ever actually read the book, or 6 people have. But I'm trying to give you the background of the person who wrote this philosophy about education, and it came in his 1929 book, Aims of Education. He was a beast of a mathematician. I'm not saying if he wasn't, but this you can take him more seriously in terms of the stage of romance. And there was actually a research journal on Whitehead in 2012. I just highlighted some keywords which are kind of dissonant in terms of education. Arousal, arouses, what's your first moment, introduction of anything? It's got to be a stage of romance. And then, of course, you have to romance yourself first. How can you romance students if you as teachers have not had a romantic intersection or been wooed, seduced by mathematics? I mean, I'm using some words which are not familiar in terms of math education. That's because we've done it through a very sterile lens of productivity and compliance. It's only worked for some people. What about the most universal purpose, right? So there's your pedagogy in a nutshell. And I wrote this article for NCTM last year about my own intersection. I'm not going to go through the stories for time purposes, but I did write about how I am where I am today because I had my own romantic intersection of mathematics in which I didn't know any of the mathematics, but I was attracted to it. And all students are capable of having some moment of attraction. So we're on the final leg, better purpose. Better purpose. I think for the most part, most people would agree, yeah, give me better content. What does it look like? Yeah, I'm good. Better pedagogy, yes, absolutely. Teachers looking for the best pedagogy. I'll tell you what, this is the one which has never been attended to. I'm doing a keynote in California next week. California Math Framework just got passed. It's amazing. But even the CMF fell short of better purpose. It's always a North American quasi-capitalistic purpose. Yeah, it's sort of, it's comforted with other ideas to make it loftier, but really, if you strip away it all, it's really just an external validation of functioning society. And that's always been. So we need to have a better purpose. And this is where I'm going to start. I just came across Christopher Havens early March. Didn't know who he was. That's his girlfriend. And that's kind of a similar setup in which Christopher would be teaching mathematics. So I'm just giving you some sort of being a bit cryptic here, but that is Christopher Havens, and he is going to set the bar for better purpose he set the bar for me, and I'm hoping he's going to set the bar for you as well. This is some of his reflections on mathematics. I purposely chose a screenshot in which you're not too familiar with what his environment could be. There's obviously some key words, the transformative power. These are all his words and change. And so he's obviously alluding to these illusions of mathematics, which are beyond what we currently have in most of our curriculum and mission statements. So he's already alluding to it. This is where Christopher Havens taught himself mathematics. You can find out the specific details. I'm at the stage where I don't like to talk about his crime. He is serving 25 years for murder. It wasn't a drug deal that went wrong. He's very remorseful for not just that crime still, but just what it did in terms of separating him from his children, and of course the person that he killed from his child yet to be born. Um, and I'll talk a bit more about Christopher in terms of what he wants to do with mathematics. But if we talk about who can do mathematics and what circumstances and all that, we have no more excuses. We have none. I mean, he learned in solitary confinement 1 year where the light bulb is left on all the time. He taught himself mathematics through first puzzles, and he got a paper published working with some Italian mathematicians. There's going to be a Hollywood movie made about him. He has a book deal. They're all recruiting A-list actors. I think Ryan Gosling and Bradley Cooper are on the list. I know this because I've been having conversations with Christopher. This was the first aha moment I got. I've spoken to him 4 times now, and I forget that he's in prison. Mathematics has elevated his life so much and brought so much joy to him. He wants to only do good now. So this idea of recidivism in terms of, return to jail, he says, I want to do something beyond that. He wants to do something called desistance, which is soon as you commit your crime, you start to make a conscious choice of moving away from that world. And mathematics is giving the tools to think about desistance for him, but also something which is called the Prison Math Project, which I will talk about. But that itself is a nutshell in terms of the power of mathematics when everything else is taken away. That's when the illumination of mathematics is the brightest, paradoxically speaking. Speaking of paradox, isn't this quote by Ed Frenkel, who wrote Love and Math, 2013, I believe, the book? Looking for it on my bookshelf. I want to show you the copy. Where there's no mathematics, there's no freedom. So if you're talking about simply the world of mathematics, Christopher is freer than our students who are in school. Mathematics has freed him so much that he has gone beyond whatever brought him into prison. And now he wants to give back, through which I'll show you the Prison Math Project in a bit. But this, to me, I even told Christopher, make sure on your new website you've got this quote here because it is pretty powerful. And this is the website. It's undergoing a transformation, which is going to be mind-blowing, but this is he's done everything from inside. This is a grassroots organization. There's people working on the outside, a lot of amazing people. It's just that they're trying to pair people up from the outside from people on the inside. And the way you communicate inside a prison is very challenging in terms of the security, what kind of information. Christopher has no access to email himself personally. He has a personal assistant that shares the email. But he's willing to do all this from inside prison because of the mathematics he intersected, which was number theory, which was some of the examples. One example I showed you of perfect numbers. It's all connected in terms of better content, pedagogy, and purpose. The last example for better purpose is a personal one. Timing's going to work out perfectly. This seems a bit cryptic. You have Timothy Gowers, who's a professor at Cambridge. He is linked to this perimeter puzzle I put on the internet. You may want to take a screenshot and give it a go yourself, because it looks like there's information missing to find the perimeter of this shape. And to let you know how much traction this problem got. And again, there's a missing screenshot that connects him to this puzzle to the higher purpose. But let me just show you that it got 500,000 views. When was the last time you saw a math problem get 500,000 views? It's just a perimeter problem. I'm going to be purposely kind of devil's advocate. It's a silly perimeter problem. What fascination could it hold? There's your missing screenshot. Timothy Gower's daughter took a crack at it. It was mood elevation. I mean, how ironic is that? The same thing which has caused so much distress, anxiety, and alienation with so many of our students was a mood elevator. Elevated oneself. There was probably, you know, some endorphin release, and Timothy Gowers is saying that in his about his daughter. And this is from Chasing Rabbits, and I never thought this quote would be so applicable, but this is what mathematics, for me, has been, continues to be, this sort of restorative agency, and it has to be a balm. If it cannot be a balm, this sort of soothing, comforting, you know, because then we have this existentialist crisis in terms of who we are. I mean, mathematics is such a part of our history. It's not about getting questions right. It's not about that, as I said earlier, you know, it's a history of slow failure. It's a history of maybe hitting that arrow once on the board and the other 9 times miss. It doesn't matter, at least you attempted. And that's been the history of everyone. And imagine if students had that knowledge, they'd feel more comforted by the fact of what math is supposed to be, right? So, and the last one, which is related to the Timothy Gowers. This is a picture of myself and my daughter taken by my friend Dennis Cholis in 2018. One of my favorite pictures of myself and my daughter. And like many students, kids, young adolescents, teenagers, she suffered anxiety and depression during the pandemic. Now, I'm up here in Ontario. We have a very good healthcare system. We have a very good public education system. Please look at that stat in that article in 2023, post-pandemic. We weren't doing well. 90%. Read that twice, 3 times if you have to. So there was a lot of students and probably teachers with mental health. This was my daughter for most of 2021. She missed most of grade 8, wasn't sleeping, wasn't eating. Took her to a psychologist for examination because she had started cutting herself in her arms and legs. And sure enough, a lot of things came back in terms of possible hospitalization because the psychologist had checked off that there was also suicidal ideation. Now, this is where you're thinking, well, is this story going off the rails? No, it's not. It's making a beeline for exactly that higher purpose. Because the way I dealt with my daughter's severe anxiety depression, I wasn't attached at all. No. I went full on in terms of my relationship with my daughter, my love for my daughter. I had to process the possibility that my daughter might not be here because of anxiety, depression, because of what happens to so many kids, and has happened to so many kids. I processed all that deeply, but I couldn't put my finger on why was I cool? Why was I tempered? Why was I so logical without still being emotional? And so before I show you why, I want to show you why it's important that when we're doing all this, that we know the stories of our children, of our students. These are word art walls from Lashana Garrison, who's an 8th grade teacher in Dubai, good friend of mine. She shared about 25 of these with me. I'm just going to share you a couple because my daughter could have made one of these word art walls. These are actual students, by the way. It's pretty powerful when we know this is an actual student who's constructed this art to share some of their history in terms of their emotions. That's not all negative, but you know, we're all a sort of melange, a collage of many things. And then this article came in 2022, August. I didn't have to even read the article. I didn't. It was when I read the headline in this Guardian article. I knew exactly what happened with myself and my daughter. In that this person was able to cope with his daughter's death of a brain aneurysm at 35. Mathematics somehow has given me the tools, the wisdom to process even things which are the most tragic. So if you just go back to higher purpose in terms of what I just said, Christopher Havens, where are our most marginalized, neglected students? So before I share that slide, again, this idea, this is Charlie, David Crummels, who played Charlie Epps in Numbers. He failed mathematics in high school. And again, he came up with a very higher level purpose of mathematics in terms of there's a spirituality there, which is very infectious. So this is where I am in 2023. This is my Venn diagram. It's got to be the highest quality of mathematics. It's got to have the highest purpose, and it's got to be for our most marginalized, neglected students. So if the Christopher Havens of the world, some of those Christopher Havens are sitting in our classroom right now, or they're actually not, they actually don't show up. But if our mathematics is not for them, if we're not going to create that sort of restorative agency bomb, then it's for nobody. I'm not interested. I'm only interested in serving those people because those people probably will have the highest outcomes, i.e. Christopher Havens, of appreciating the world of mathematics. So this is the CMF. This is a blog I wrote about it. It's actually it has the potential for hope, healing humanity, something which I've talked about at least indirectly, implicitly in this presentation. So if it's available, even if you're not from California, it is really a positive move in the right direction of taking us at least on a ship in terms of better content, pedagogy, and purpose. This is from the framework. I circled this, these words, promise, right? The promise here of enabling California students. The reason why I circled that, because that word promise is in a 1956 Mark Launer print, which I shared with Nick and Chris previously. You can't find a better image, which is kind of cool, because there's a part which is needs to be unfurled, but it's called the eternal promise of children, this magical romantic treehouse of all possibilities. And the part that's missing, that's been curled up, again, you can't find a complete perfect one. What's underneath it? What's underneath it as our last slide to take us out? Just let them go free, and they're going to change the world. So the whole idea about freedom in terms of mathematics at Frenkel, where there's no mathematics, there's no freedom. And as far as at least the branch of this tree in terms of mathematics, they will never be able to change the world if they don't get the richest mathematic content, pedagogy, and purpose possible. Thank you very much. Finished at 2:50 perfectly. I don't think I ever timed a better presentation. So yes, that's it for that.
That was beautiful, Sunil. I always appreciate your sharing of these stories, and every single time you talk, I'm like, man, if only you would have been my math teacher, I would have been like the happiest person. Really quick, I did want to take a few questions as they come in,
Sure.
just like in a couple of minutes or so.
Sure.
Jack, did you want to have a question in the chat, or are you unmuted?
No, actually, I did ask a question in the chat earlier about times tables as kind of an obsession in some classrooms, and if Sunil would care to comment on how he sees the use of them.
Well, again, I think I mentioned very quickly because I was just pressed for time. I'm all for math facts. In fact, I mean, I rattled off, facts about perfect numbers and things like that. But in terms of times table, the obsession, here's my pushback, and not even a pushback. So if you have 6 times 7 is equal to 42, okay, that's a math fact. But what I would rather have students learn is 2 times 3 times 7 is 42, because now 42 is broken down into its prime constituents. Now you can have primes. But if you know that 2 times 3 times 7 is 42, if you would take out one number, let's take out the 3. How about you 2 times 7? Well, that's 14. Put the 3 back in. Well, 14 times 3 must equal 42. You create a family of math facts if you take that extra step in breaking down those inert math facts. So I'm all for factual fluency. It's just the factual fluency which is being addressed is not as good content.
Speaking to that, I think this heavily relates from Mason, which is like, obviously, like this is not something that's taught in school for a lot of folks. Like this is the first time they'd be learning about something like this. So for a teacher who maybe is a math teacher or someone who wants to work with a math teacher to invite them in, where would they go to learn more? Like where could they learn these lessons and stories?
Well, it's I mean the every story, and that's really important, but that's a great question. Because teachers are always looking for resources. First of all, this didn't occur, everything that I could share with you. You know, Amazon didn't show up with a whole bunch of books on my doorstep in 2020 or 2019. This is like 20 years, slowly, every night. I was a teacher, classroom teacher, but I just became interested in mathematics as it wasn't matching up with the mathematics that I learned or taught. So let me find out more. And the internet was this massive treasure chest. And it was just like, even up until today, I'll still search something. So I would just say the internet, it's a great resource. Mathagon is a free resource with its math history timeline. I would definitely start there because they give you nice thumbnails of every mathematician. Then you can dig further. That's where I got those images from. But I love that question because it really addresses what I think is really important. As far as I'm concerned, I don't want a teacher who necessarily knows a lot. I'm interested in a teacher who wants to know a lot. There's a big difference because I know a lot of teachers, high school teachers, who know a lot, but they capped off their learning 35 years ago. Like they just locked that box and they don't want to know anymore. Whereas if there was a third grade teacher from a dramatic arts background who was first year teaching, but goes, that's like my first year teaching third grade math. How about I learned third grade math with you? My kids are going in that class every time. So it's that romance stage. Like you are a learner first. You are a learner forever in mathematics. You talk to university professors, they see themselves as learners, not experts. They're learning all the time in research. So just be curious. Don't be incurious. That's the only ticket you need to get on the math train, is to just be curious, and you don't have to learn everything by a certain timeline.
Amazing. Again, thank you so much, Sunil. I think that's a perfect wrap up, a great final line, if you were. Yeah, I again appreciate you being here. If people want to learn more, I know you have a website that's like in the works.
In the works,
But
yeah.
otherwise, they can follow you. What's at
On
Math
Twitter,
Garden?
at Math
Yeah.
Garden. Yeah, I'll be there until, as was intimated, until it all collapses in a smoldering. But yeah, I'll be there, and you know, I'm always posting stuff. And if people want to connect with me on Twitter or just you know, even email, I'll just type it in right now. If they just want to continue the conversation in a more static way for ideas, and so I can learn more about their background, then definitely do that as well.
Awesome. And just for the record, because I might forget to put it on the YouTube comments, it's rightanglemath@gmail.com.
Yes,
So
yes.
just so
Thank
you're
you.
aware.
Perfect.
Awesome. Cool. Well, thanks again, Sunil.